Welcome back. In the last module, we learned how to use the chain rule to differentiate composite functions. In this module, we're going to learn how to differentiate the product of two functions using something called the product rule. In Day 8, we learned that composing one function with another was a particular way to combine the two functions together to form a new one. Another, and arguably easier method, is to simply multiply the two functions together to form what is known as a product function. Here are some examples of product functions. Notice that the first two examples can be differentiated by first expanding the brackets and then using the power law on each term. However, this doesn't work for the third example. Indeed, to differentiate complicated functions, like the third function above, we need something called the product rule. The rule states that if we call one of the functions u, and the other one v, then the derivative of their product is equal to the function u times the derivative of the function v, plus the function v times the derivative of the function u. If you prefer to call the component functions f of x and g of x, then the product rule can be written as f times g dash plus g times f dash. So rather than differentiating the first function we considered earlier by expanding everything, let's use the product rule instead. Letting u be the first function x plus 1, and v be the second function x squared plus 3, the product rule states that the derivative dy dx is therefore given by u times the derivative of v plus v times the derivative of u. That is, x plus 1 times the derivative of x squared plus 3, which is 2x, plus x squared plus 3 times the derivative of x plus 1, which is just 1. Which gives us the following upon expanding the brackets. And this simplifies to the following. Similarly, rather than differentiating the second function we considered earlier by expanding everything, let's use the product rule instead. Letting u be the square root function x to the half, and v be the cubic polynomial x cubed minus 3x squared plus 7, the product rule states that the derivative is given by u, that is x to the half, times the derivative of the cubic polynomial v, which is 3x squared minus 6x, plus the cubic polynomial v itself, times the derivative of u, which is a half times x to the negative half. Finally, let's now differentiate the third function we considered earlier, which can only be differentiated using the product rule. As usual, letting u be the function t, and v be the function e to the t, the derivative dy dt will be given by u times the derivative of v plus v times the derivative of u, which simplifies to the following. Alright, time's to pause the module and have a go at the following practice questions. And here are the answers.